Hello friends, welcome to Physics by GD. So today we are going to solve the Mathematical Physics by H.K.Dass, which means we will be providing the solution of the unsolved problems in this book. So here we are going to start with the first chapter, which is review on vector algebra. So we are starting with the first exercise, which is 1.1. So the question number 1 says that we have to find the volume of a parallelepiped whose adjacent sides are this: OA bar, OB bar and OC bar. And one more thing is given, it is extending from origin of coordinate O, which means all these vectors have a common point from where they are originating, which is point O, and it is at the origin. So as we know that the volume of parallelepiped is equals to the scalar triple product of three vectors. So we will take the scalar triple product of this vector. So OA bar is 3 I cap minus j cap. So it is 3 minus 1 and 0. And OB bar is I cap j cap. So 0, 1, 2. And similarly OC bar is 1, 5 and 4. So we will take the determinant of this values. So let us calculate 3 into 4 minus 10, and it is 1 minus 1 plus 1 into 0 minus 2 plus 0. So it will give us 3 into minus 6 minus 2, which is nothing but minus 20. But we know that the volume is always a positive quantity. So whenever you will get a negative sign, just neglect the negative sign, because our volume is always positive. So it will be equal to 20 unit. So let us now move to question number 2. So in question number 2, we have to find the volume of a tetrahedron whose vertices are points A, B, C and D. So we have to find the tetrahedron whose points are been given, right? So in this type of problem, we have to make one point as our common point. So let us make point A as our common point. So AB will be equal to 4 minus 2 I cap, 1 minus 1 I cap, j cap, and 3 minus 3 k cap. So we will get this is 2 I cap and this is equals to 2 j cap and this is equals to plus 6 k cap. Similarly, we will calculate AC bar and AD bar. So AC bar will be equal to 3 minus 2, which is I cap, and 2 minus 1, which is plus 3 j cap, and minus 1 minus 3, which is equals to plus 2 k cap. And AD bar will be equals to 2, 1. So we will get minus I cap, 4 minus 1 plus 1. So it will be 5 j cap and 2 minus plus, so 5 k cap. So we have been given a tetrahedron whose vertices are this 4 point. We have taken one point as a common point, and we will calculate the, as we know that the volume of tetrahedron is equals to 1 by 6 times the scalar triple product. So it is equals to 1 by 6 of, this is 2, 2, 6, and this is 1, 3, 2, and this is minus 1, 5 and 5. So it is equals to 2 into 15 minus 10 minus 2 into 5 plus 2 plus 6 into 5 plus 3. So it is 1 by 6 into, this is 10 and this is 14 and this is 8 6 are 48. So it is around 10, so minus 4, and it is 44 divided by 6. So we will get this value So it is equals to 22 divided by 3 units. So in question number 3, we have been given three vector a bar, b bar and c bar, and we have been given that these vectors are linearly dependent. So we have to find this unknown value y. So simply we know that whenever a vector is linearly dependent, its scalar triple product is always 0. So a bar scalar triple product a bar, b bar and c bar is equals to 0. So 7 y 1 3 2 1 and 5 3 1, this will be equal to 0 if the vector is linearly dependent. If it is independent, then it is not equal to 0, but we have been given it is dependent. So 7 into 2 minus 3 minus y into 3 minus 5 plus 1 into 9 minus 10 equal to 0. So this is minus 7 minus y into minus 2, which is 2y, and this is again minus 1 equal to 0. So 2y is equals to 8. So y equals to 4. So this is the value of y. So in question number 4, we have to prove that a plus b, that is scalar product of this thing, is equal to 2 times scalar product of abc. So as we know that the scalar product a bar, b bar, c bar is been written as a bar dot b bar cross c bar, right? So let us start with first LHS, which is a bar plus b bar, b bar plus c bar and c bar plus a bar. So we will write this thing in terms of this thing. So it will become a bar plus b bar dot product of b bar plus c bar cross c bar plus a bar and bracket. So let us simplify this thing. So it will become a bar plus b bar dot product b bar cross c bar plus b bar cross a bar plus c bar cross c bar plus c bar cross a bar. So we know that the cross product of same vector is always 0. So this thing is equal to 0. So it is a bar plus b bar dot b bar cross c bar plus b bar cross a bar plus c bar cross a bar. So let us multiply a vector with this thing and again b vector with this thing. So this is a bar dot b bar cross c bar plus a bar dot b bar cross a bar plus a bar dot c bar cross a bar and plus b bar dot b bar cross c bar plus b bar dot b bar cross a bar plus b bar dot c bar cross a bar. So as we know that whenever there is two same vector in scalar triple product, it will always will be 0. It will always become 0. So here it will become 0, this term will also become 0 and this term again will become 0, and again here b is same, so it will also become 0. So this will, so finally we will be getting a bar dot b bar cross c bar plus b bar dot c bar cross a bar, right? So here this is a dot b bar cross c bar and this is b dot c bar. So we can make it, so this thing and this thing is same, as we know that a bar b bar c bar is equals to b bar c bar a bar and this is equals to c bar a bar and b bar. This is the identity, है ना? So this both things are same, so it will LHS will be equal to 2 times a bar dot b bar cross c bar, which is nothing but same thing, so which is nothing but RHS. So hence we have proved this.